So there's precedent. I mean, so the thing about mathematics is that it's really good at spotting connections between what you might think of as completely different problems. But if the mathematical form is the same, you can draw a connection. Um, so there's a lot of work previously on what are called cellular automata. The most famous of which is Conway's game of life. There's this infinite discrete grid, and at any given time, the grid is either occupied by a cell or it's empty. And there's a very simple rule that tells you how these cells evolve. So sometimes cells live, and sometimes they die. And there's, when I was a student, it was a very popular screensaver to actually just have these animations go on, and they look very chaotic. In fact, they look a little bit like turbulent flow sometimes. But at some point, people discovered more and more interesting structures within this game of life. So, for example, they discovered this thing called a glider. So a glider is a very tiny configuration of like 4 or 5 cells, which evolves and it just moves at a certain direction. And that's like this vortex rings. So this is an analogy. The game of life is kind of like a discrete equation, and the fluid Navier-Stokes is a continuous equation, but mathematically they have some similar features. So over time, people discovered more and more interesting things that you could build within the game of life. The game of life is a very simple system. It only has like 3 or 4 rules to do it, but you can design all kinds of interesting configurations inside it. There's something called a glider gun that does nothing but spit out gliders one at a time. And then after a lot of effort, people managed to create AND gates and OR gates for gliders. Like there's this massive, ridiculous structure, which if you have a stream of gliders coming in here and a stream of gliders coming in here, then you may produce a stream of gliders coming out. Maybe if both of the streams have gliders, then there'll be an output stream. But if only one of them does, then nothing comes out. Mm-hmm. So they could build something like that. And once you could build these basic gates, then just from software engineering, you can build almost anything. You can build a Turing machine. I mean, it's like an enormous steampunk type things. They look ridiculous. But then people also generated self-replicating objects in the game of life. A massive machine, a polynomial machine, which over a huge period of time, and it always looked like glider guns inside doing these very steampunk calculations, it would create another version of itself, which could replicate